Welcome to the first example of floating point. So we have negative 5.75. So let's see how we are going to do this. First of all, let's assume that we don't know that there is any negative attached to it. So we will pick, so we are going to pick the 5, that is the number, and express it to base 2, to base what? 10. So from base 2 to base 10, when you convert this, that's when you do something like this. So 2, 5, then the remainder will be here. So 2 here, 2 goes to this. Alright, 2, remainder 1. 2 goes to this, 0, remainder 0. Sorry, 1, remainder 0. So now we pick our number from here, that's a number of 5 in base 2 is going to be 1, 0, 1 in base 10. Alright, so after this, after picking the number, then we are going to also pick the rest. What is the rest? The rest will be 0.75, because if you add this to 5, you will still get the same thing, right? So we are now going to pick 0.75 and convert that one to base what? 2. Convert from base 2 to base 10. Alright, so let's see how we are going to do that one. So first of all, you multiply this, the whole of that, by 2. And what will you get? When you do that, you are going to get 1.5. Then the results you will get. Anytime, since we are saying that the floating point is in the form of a binary numbers, and binary numbers is zeros and ones, right? So when you get 1, then you pick the other number, right? So when you get 1, ignore and pick the other number, which will be 0.5. So here you multiply 2 by 0.5. You see that, and what will you get for that? Which is 1. Which is 1. Now you see that now we have 1. If you have 1, it means that you cannot go again. If you get 1, it means that you will not go again. So you are going to pick, so this one is like 0.0. How we can see that? Alright. So we are now going to say that 0.75 in base 2 is going to be, then we pick the numbers here. How you can see that? Alright. So that one will be 1, 1 in base 10. Therefore 5.75 will be in base 2 will be equal to, then you bring this one first, because that's the first one. You bring this one first. 101 point, because of the point there. Then you will bring this conversion, which is 1, 1. So that is that. That is that. Alright, so from here, then we move to where we are going to float it to last what? Digit. So this number that we are going to float it to the last what? Digit. Alright, you can bring this one in. So we are going to float these results by the last one digit. And we know the last digit to be what? 1. So when you float 8, so floating, let me write it for you, okay? Floating to the last digits. So when you float what you have to the last digit, what will you do? 1, 2, right? So you get 1.0111. How we can see that? And since we were moving to the left side, it means that it's going to be positive. So 10 raised to the power 2. So that's what we have for now. Alright, so from here then we go to the what? The exponent. The exponent. Or you let's go to the sign. The sign. So what will be the sign? The sign is negative. And we already established that if it's negative, it means you write what? 1. So that is for the sign. Alright. So now let's move to exponent. Let's see what the exponent will be. Now, the exponent is the power, okay, plus 127. Alright. So, from what we have, what is the power? 2. Okay. 2 plus 127. So, what is going to be the result? That is 129. Now, this 129 that you have, you also convert it again. So when you convert, from base 10 to, so from base 10 to base 2. So here 129 in base 10, then you convert it to base 1, 2. So with this, you can do it on your calculator. You go to mode, then you go to 4 where we have the base, right? Okay, then you press the number 129. Press equal to, after pressing equal to, then shift, and where we have the log, you see, and then we have the bin. So shift log. Then you see that we have, forget about where the 00 is, and start from where you have the 1, and start writing it. 1 0 0 0 0. Be careful when writing it. 0 0 0 0. Okay. 0 0 1. Alright. So 1 2 3 4 5 6 7 8. Remember that we said you are floating it to what? A single, right? And the single, the exponent for the single is what? 8. So this you end it. And you see that from the calculator we have it up to 8, that's all. Not always that after counting you get the 8. It depends on the question. Well, I think we have such question. We will look at it and you see what I'm talking about. So this is Mantiza. Okay. So that is the Mantiza. So floating to the last degree, that is where you do the Mantiza. And the Mantiza should be in what? We are being single, so that is 23. But what we have here is what? 0 1 1 1. You see what we can do about it. So now let's write our final results. I'll get back to you. Alright, so now that we have our Mantiza, the sign and the exponent, we can now write our floating point. So this is where we are going to start. We start with the sign. The sign, it gets 1. And it gets 1 digit. That's what I mean. I'm not saying it's always 1. So since the sign was negative, we have 1 here. Then you come to what? The exponent. The exponent. And exponent should be what? 8. Okay. What we have there, what is that? Okay, where is it? 1 0 0 0 0 0. I think 4 zeros, right? 1 2 3 4 5 6. 1 2 3 4 5 6. Then 1. Alright. So when you count 1 2 3 4 5 6 7 8. Okay. So that is the exponent. Then you move to where? You move to the Mantiza. The Mantiza should be what? 23. Alright. So this is where you pick your Mantiza. Don't consider this, just only this. And what we have there? 0 1 1 1. Right? Now, since we want to get 23 numbers, then you continue writing the 0 to get 23. 1 2 3. So 1 2 3 4 5 6 7 8 9 10 11 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yeah, so now that we have the 23, that means that this is going to be our mantissa. This is going to be our mantissa. So we have the mantissa here, the mantissa here, the sign and exponent. Alright, so that brings the end of this question. We will look at question 2 right now.